Okay, let's dive right into this vital intelligence briefing. Think of this as your essential toolkit. We designed this explainer specifically to equip you, our new industrial health and safety managers, against the invisible enemies lurking in the workplace. Today, we're going to break down the science, decode the regulations, and check out the tools you need to keep your teams completely safe from toxic substances. So, here's our threat assessment syllabus. We're going to identify these invisible workplace threats, break down their biological mechanisms, decode the regulatory laws, calculate exposure, and finally, deploy our detective gear.
Section 1. The Invisible Workplace Threats. Knowing the environment.
Right, the absolute first step of any investigation is understanding the environment where these hazardous materials actually operate. As a new health manager, your primary concern is to put a hard stop to toxic exposures. The goal is crystal clear: assess the threat before it strikes. Dealing with exposure to toxic substances is basically the classic health problem in our field, and solving it requires knowing exactly how these threats physically enter the workspace. We have to know what we're looking for, right?
Because these contaminants, they aren't just mysterious clouds floating around. They infiltrate specific parts of the body in very specific ways, depending on their physical state. Gases, well, they readily mix into the air and can penetrate deep, right into the alveoli of the lungs and cross straight into the bloodstream. Vapors, which are just small gas quantities bleeding off from liquids or solids, do the exact same thing. Then you have mists. These are tiny suspended liquid droplets that often settle and really irritate the upper respiratory tract. And finally, dusts. These are tiny solid particles that can mechanically scar deep lung tissue. Knowing the state of the contaminant tells you exactly how it behaves, and more importantly, how it enters the human body.
Section 2. Categorizing toxic substances, the suspects, MO. Now let's move on to categorizing our main suspects and analyzing the precise biological mechanisms they use to attack vital organs. Let's look at how these substances actually do their damage. On one side, we've got irritants. These basically inflame the surfaces they touch. Take ammonia, for example. It combines with the body's natural moisture to form ammonium hydroxide, which is a strongly caustic agent. Or consider dusts, which act as mechanical irritants, causing pneumoconiosis and fibrosis, essentially scarring the lungs from the inside. But then we have systemic poisons, and these are far more insidious. Instead of just surface irritation, systemic poisons literally attack vital internal organ systems. Heavy metals like lead directly attack the blood, the digestive system, and the brain. Others, like mercury and cadmium, they go straight for the kidneys and liver. You absolutely have to know the mechanism to understand the true severity of the threat.
Another major category of hazard is asphyxiants. The crucial point to understand here is the biological mechanism, specifically how they deprive the body of oxygen. Simple asphyxiants physically crowd out the essential oxygen from the air. You simply can't breathe because, well, the oxygen just isn't there. Chemical asphyxiants, on the other hand, are much more deceptive. They literally interfere with blood oxygenation inside your body. You might be inhaling air just fine, but the chemical blocks your blood's ability to actually carry that oxygen to your tissues. It's a completely different biological mechanism, but it has equally fatal results.
Then we have a number that should absolutely be seared into the mind of every safety manager: 20 to 30. When we talk about carcinogens, substances known or suspected to cause cancer, we are dealing with a terrifying latency period. It can take 20 to 30 years between a worker's exposure on your watch and the actual appearance of cancer. Vinyl chloride is a perfect example of this. It presents a severe chronic inhalation risk that can silently lead to a specific form of liver cancer decades down the line. This is exactly why you absolutely cannot wait for symptoms to appear. By the time someone actually feels sick, the damage was done 20 years ago. Carcinogens demand absolute proactive protection from day one on the job. No exceptions. Section 3. Decoding exposure limits. The laws of safety. Okay, so knowing the enemy is only half the battle. Now we need to understand the exact regulatory boundaries that separate a harmful environment from a benign one. Because, no poison is lethal in a small enough dose, and all poisons are lethal in a large enough dose. We need a clear-cut line. That line is the threshold limit value, or TLV. It refers to the level of concentration below which a worker could be exposed during an entire workday without significant harm. A threshold limit value isn't just some casual suggestion. It is the scientifically agreed upon line in the sand for daily full-shift worker exposure. Every single toxic substance has its own specific TLV. Let's quickly clear up the acronyms that govern these limits because, let's be honest, it can get a little confusing out there. First, ACGIH, the American Conference of Governmental Industrial Hygienists. They are the actual committee that lists and agrees upon these TLVs, publishing them as a standard. Then we have NIOSH, the National Institute for Occupational Safety and Health. NIOSH is the agency that does the heavy research lifting to propose recommended exposure levels, or RELs, to OSHA. Together, these organizations form the absolute backbone of regulatory safety limits.
Section 4. Calculating time-weighted averages, measuring the threat.
Now we move from theory to practice. How do we mathematically prove our workers are safe over a long, variable shift? This is where the time-weighted average, or TWA, comes into play. The TWA is a computed weighted average concentration of air contaminants calculated over a standard 8-hour shift. Listen, the time-weighted average is your most powerful mathematical tool for monitoring an entire shift, rather than just panicking over a single isolated moment in time. Contaminant levels fluctuate, right? Sometimes they're high, sometimes they're low. So we need an equivalent average to actually check against those legal limits we just talked about. To calculate this, it's a simple but absolutely vital formula. We take each time period in hours, multiply it by the observed concentration during that specific period, and we get a value. We sum all those values up, say reaching 33 in this scenario, and divide by the total 8 hours. That gives us a TWA of 4.125. Doing this ensures the overall exposure stays safely under the legal limit, even if there were a few brief spikes during the workday. But wait, what happens when your workplace isn't just dealing with one chemical? In real-world environments with mixed substances, you have to calculate an equivalent ratio for all hazards combined. First, identify the concentration of each contaminant. Second, find the permissible exposure level, or PEL, for each one. Third, divide the observed concentration by the PEL for each substance to get a ratio. Finally, you just sum all those ratios up. The absolutely crucial rule here is that the final number can never, ever exceed 1. If it goes over 1, the combined synergistic effect is both legally and biologically unsafe. Section 5. Detecting hazards, the detective's gear. Let's see how all this builds into our final capability, actually deploying the instruments to detect what our human senses simply cannot. Here is a golden rule for any safety manager. Never trust your nose on a sidewalk. Seriously, the invisible motif of industrial safety is that our senses are totally inadequate. Deadly hazards, like chemical asphyxiants such as carbon monoxide, are designed by nature to be entirely colorless, tasteless, and odorless. They're completely invisible, meaning your instruments are your absolute only line of defense. And here we contrast your essential toolkit. On one hand, we've got detector tubes. These are brilliant for immediate on-site chemicals spot checking. They contain a chemical that physically reacts and changes color if a suspected contaminant is present right then and there. On the other hand, we have dosimeters. These are worn directly by the worker and continuously track their exposure throughout the entire shift. They literally collect the raw data you need for those time-weighted averages we just calculated. Ultimately, all of this complex threat data needs to be communicated quickly, especially in an emergency. And that's summarized beautifully in the NFPA Diamond. It provides emergency responders and safety managers a really quick visual representation across 4 fields: health in blue, fire in red, reactivity in yellow, and special hazards in white. It uses a 0 to 4 scale, giving you an instant read on the absolute danger at a mere glance, where a 4 means extreme danger. Which brings us to the ultimate question. The tools are in your hands, the regulatory laws are clearly defined, and the biological stakes, as we've seen, are quite literally life and death. Armed with these limits, the math to calculate exposure, and the gear to detect the undetectable, new managers, are you ready to step up and secure your site? It is a massive responsibility, but one that can absolutely be managed with the right knowledge. So, think about it. What kind of legacy of safety are you going to leave behind?